Okay, folks, last page. Isn't this exciting? These are just descriptions of problems. They want us to solve simple math concepts with them. The first one is the classic cone problem, where you have a conical water tank. And they say that the dimensions of the tank are, the tank is 10 meters high, and it's got a radius of 3 at the top. So it wants to know if the water is 5 meters deep, what's the surface area of the water on the top. Well, this is using proportions. We're gonna, because the cone is gonna have the same similar geometry as the water height changes. So we should have a ratio of 3 to 10 for that for the overall tank. Should equal 5 to what the radius would be when it's 5 high. So we cross multiply. We find the radius is going to be 15 over 10, or 1.5. And then we use that to find the surface area. And the surface area of the tank is going to be using pi r squared, because it's circular at the top of a cone. So we'll have 2.25 pi as our area of the water. Now we have two cards. They start out from the same point and they move at right angles to each other. So if this is the point they start at, and one moves south at 100 kilometers per hour, and one moves west at 50 kilometers per hour, how far apart are they 2 hours later? Well, you have to think about basic distance equals rate times time. You're going to have 2 hours later, this distance will be 100 kilometers, and this distance here will be 200 kilometers. So the distance between them we'll use, because they moved at right angles to each other, will be the Pythagorean theorem of 100 squared plus 200 squared, which is not 300 squared. So whatever that works out to be using your calculators, that's how you would solve that. And the last one is where we have a kite flying above the ground, and there's 200 meters of string out, and it says that it's 100 meters above the ground. So can you figure out what this angle is between the string and the ground? Assume that the string is perfectly straight. That's a good assumption to make, because a lot of times you see on the beach the string bows a bit, so we're not going to worry about that little problem. And so we have a right triangle, and so the ratio between those two sides, the trig ratio that we would use would be, because we have opposite and hypotenuse, so we would use the inverse sine of 100 over 200, and that's the same as the inverse sine of 1 over 2, which is 30 degrees, or for you radian people, pi over 6 radians. Okay, anyway, that concludes the packet. I hope you found these videos helpful. It's the first year I've tried doing this. I'm using it to help accelerate us through the course, but also give you the opportunity to look back at these if you need to, as we get ready for our summer homework test. So looking forward to seeing you in the first few days of school, and I think this year should be a good year. So thanks for watching, and we'll talk to you in school. Take care.